the last two sessions of removal and replacement, we have totally discussed 12 questions. We have totally discussed 12 questions. If I remember right, first day I discussed only 5 questions in removal and replacement. Second day, that is yesterday, I discussed 7 questions which are of little different varieties, where I solved some of the questions in method 1, method 2 and method 3 also. Now what we will do is, before I start my 13th question on removal and replacement, which is also a very important question, what I will do is, I will take the first question which I discussed day before yesterday, not just because Praveen Kumar is requesting me to go through that, but I also want to take this first question so that I can draw a very similarity between the first question and the 13th question what I will be discussing in today's class. It is just not because Praveen Kumar is asking in the live chat to revise whatever we have discussed in the first 2 classes, but I really want to take the first question once again and also solve it in method 1 and method 2, which we implemented in our first day of removal and replacement, and use the same analogy and conclude one important conclusion in my 13th question, which is the continuation of yesterday's class. Everyone listen to this carefully, sir. Although you might have attended my previous classes, don't ignore this first question. Don't ignore this first question. I will solve it in both methods, 2 methods which I also solved day before yesterday. But having said that, listen to this carefully. There is an important conclusion out of it. Now see here, sir. I will explain you the question in the diagram itself. Suppose, for example, this is a vessel. This is a vessel. Initially, I have initial volume as 1000 ml of pure milk. Initial volume is 1000 ml of pure milk is present. Everyone listen to this carefully, sir. What I will do is, I will take out 100 ml of milk outside the vessel. I will take out 100 ml of milk outside. I will add 100 ml of water. I am sure that people who have attended my yesterday's class or day before yesterday's class, both should be clear with this problem. But don't ignore it. There is a very important conclusion which I want to derive from this question to the 13th question of removal and replacement. Now once I add water, it is no more pure milk. It becomes a solution. That means I will take out 100 ml of solution out of it and I will add 100 ml of water once again. Similarly, what I will do is, I will take out 100 ml of solution once again out of the vessel and I will again add 100 ml of water into it. My question for you is, what is the final volume of milk and water in the resultant solution or in the final solution? Final volume of milk and water. That is what they are asking you in the question. Now see here, sir. I do not want your answers in the live chat. I know that you can solve this question, and that too probably if you have practiced whatever I have taught in the last 2 days, you can solve it without using pen. But that is not my intention right now. No, my intention is not to ask you the answers for this question. My intention is to teach you again method 1 and method 2 which I have taught earlier. To same thing I will take it and I will join it for the 13th question. Listen to this carefully. There are 2 parameters. One parameter is milk, other parameter is water, and the last column I can take it as total volume which is present. Now listen carefully. Initially 1000 ml of milk is present. No water is present initially. So 1000 plus 0, total volume is 1000. Now what is the first step? I am taking out 100 ml of milk out of 1000 ml. Same logic like I discussed yesterday and day before yesterday. 100 out of 1000 is taken out. That means 1 by 10 is taken out. Remaining is 9 by 10. I will not explain how 9 by 10, all those things again and again, sir, that I have been doing from the last 2 days as well. 1 by 10 of mixture is taken out or milk is taken out. Remaining is 9 by 10. That means initially it is 1000. For this 1000, 1 by 10 is taken out. Remaining inside the vessel is 9 by 10. So 10 into 1, 10 into 100. So 100 into 9. Remaining milk inside the vessel right now is 900. Now I am adding 100 ml of water into the vessel. 100 ml of water is added. Again the resultant or total volume became 1000, right? Again the resultant or total volume became 1000. That means first step and second step, the total volume still remains the same as 1000. Now see the next one. Now 900 ml of milk is present as of now, and 100 ml of water is present as of now. Now what is the third step? What is the third step that we are doing here? Third step is totally 900 ml of milk is present and 100 ml of water is present, or in general total volume still remains as 1000 itself. Total volume still remains as 1000. 100 ml of solution is taken out of 1000 ml. 100 out of 1000 is taken out. 1 by 10 is taken out. Remaining is 9 by 10. Remaining inside is 9 by 10 milk, and remaining inside is 9 by 10 water, because it is solution 1 by 10 taken out. 1 by 10 solution taken out means 9 by 10 solution is there inside. Solution is a combination of both milk and water. So I should multiply 9 by 10 for both milk and water. So 0 cancels. 90 into 9 is 810. 100 into 9, sorry, not 100, sir, yes. So this is 10 cancel. 10 into 9 is 90. That is third step. Step number 3 is completed. Step number 4 says 100 ml of water is added again. That means for this 90 ml of water which is present, I will add back 100 ml. Total water present now is 190. Total milk is 810. 190 plus 810 again happens to be 1000. That means after 4 steps also, it is still 1000 ml which is present inside total volume. It is still the 1000 ml total volume which is present inside. Now, as of now 810 ml of milk is present. As of now 190 ml of water is present. Now fifth step says, let me use a different color. Fifth step says 100 ml of solution is taken out of 1000 ml of total volume. 100 out of 1000 is taken out. 1 by 10 is taken out. Remaining is 9 by 10. That means I can say 9 by 10 milk is remaining, 9 by 10 water is remaining inside. So 10 cancels. 81 into 9 is 729. 190 into 9 or 19 into 9 is 171. Now this completes step number 5. Step number 6 says I again added 100 ml of water. That means for this 171 I added 100 ml of water. It became 271. So final volume of milk inside the vessel is 729. Final volume of water inside the vessel is 271. But the total volume which is there inside the vessel right now is also nothing but 1000, which is nothing but 729 plus 271. That means one simple conclusion from this. Listen to this very, very carefully, sir. One simple conclusion is, what is the final ratio of milk and water? Final ratio of milk and water is 729 is to 271. Final ratio of milk and water is nothing but 729 is to 271. Now, if I add these two, 729 and 271, I will get it as 1000. That 1000 is nothing but the initial volume or the total volume which is present in the vessel. That means final ratio of milk and water, the final ratio sum will always give you the initial volume or the total volume. Do not ever forget this concept. I will come back to this concept in some time, but definitely you need this concept for your better understanding of some higher level questions. Final ratio sum, the sum of two parameters in the final ratio is nothing but equal to the initial volume, or it need not be initial volume always. It can be multiples of initial volume as well. That means 729 plus 271 is 1000. Initial volume should be a multiple of 1000. Yes, in this question, initial volume is 1000. That is nothing but a multiple of 1000 itself. I hope this clear. This is very, very clear for you people. Now, this is my method 1, which I already taught you on day 1 itself. Method 2. This also I taught you on day 1, but there is a reason behind discussing again, sir. Just like that, I will not say again and again. What is the key point we discussed? Always work with the parameter. always work with the parameter that is decreasing. Always work with the parameter which is decreasing. Now, what is decreasing in this question? Milk is decreasing. You know this already. Milk is decreasing. That means because milk is taken outside the vessel, milk is decreasing. I am finding the final volume of milk in this case. Listen carefully, sir. Now everyone observe carefully. Everyone observe carefully. Total volume initially is 1000. Total volume initially is 1000, but my question for you is initially total volume is 1000 and I am finding milk parameter. Is that entire 1000 ml whatever it is there initially as total volume, is it completely milk? Yes, it is completely milk. That means this initial volume 1000 whatever is present right now, it is completely milk. It is a pure milk. No other adulteration has happened. Nothing has been added yet. Nothing has been added initially. That means initial volume of 1000 happens to be completely pure milk. And I am also finding a milk parameter in this question, which is the final milk. So whatever 1000 I am writing here is nothing but initial volume, but that entire thing is 1000. That entire 1000 is milk itself. Therefore, I can write 1000 entire thing here. I hope you are understanding. You will understand it better when I take 13th problem. Do not worry about it. And then the same procedure. 100 out of 1000 is taken out. 1 by 10 is taken out. Remaining is 9 by 10. Again 100 added. Again it became 1000. 100 out of 1000 is taken out. 1 by 10 is taken out. 9 by 10. Again it will be 100 added. 100 taken out. 1 by 10 taken out, 9 by 10. These are all something which you know, sir. So it is 1000 cancels with 1000. 729 should be milk. Water should be 1000 minus 729, which is 271. I hope the idea is very, very clear. Milk is 729, water is 271. Milk and water ratio is 729 is to 271. When I add it, I will get 1000. That 1000 is nothing but my initial volume. This also is a very, very important point which I explained in method 1 as well. I hope method 1 and method 2, whatever I have discussed in my first class on removal and replacement, there is a revision for new students who are attending for the first time. But other students who have attended my last 2 sessions on removal and replacement should have supreme confidence in this kind of problems at this present moment. Before I move on to 13th problem on removal and replacement, first I request you to comment whether this is clear or not. This is clear or not, I want to know it, sir. Once again I am saying I am actually trying to find the parameter of milk, final volume of milk. Final volume of milk is initial volume into something, but this initial volume is 1000 in this question. It is given in the question as 1000, but the main important point here is that entire 1000 ml only referring to milk? Yes, it is only referring to milk. That is the reason I can write 1000 here. If it is not entire thing 1000 milk, then I should write how much milk is present here as the initial volume. That we will see it in our 13th problem. Do not worry about it.